This is Euclid Book 2, proposition number 7. And what we're going to do here is we're going to get one step closer to Euclid Book 2, proposition number 11, which is the quadratic formula. But let's start with this proof here, and I'm going to read this to you word for word, and then I'm going to explain it. If a straight line be cut at random, the square on the whole and that of one of the segments both together are equal to twice the rectangle contained by the whole and the said segment and the square on the remaining segment. Okay. Now then, here is the simple explanation. You see this line here? And you see this line here? Well, this rectangle is contained by this line here and this line here. So you got AC and CG. So the area contained by these two lines is what he's talking about. Alright, now what about the square? Well, do you remember in the Pythagorean theorem, Euclid Book 1, proposition number 47, where we drew an entire square underneath the line, and we had a line here and a square here and a line here and a square here? That's what he's talking about, the square of this line and the rectangle contained by these two lines here. Alright, now, let's go into the heart and soul of this proof. ADEB is a square. He's going to have you draw a square, and it's going to be called ADEB. Okay? Now, that's by Euclid Book 1, proposition number 46. Now, AHGC, this area here, is equal in size to GNEF. GNEF. This area here is equal in size to this area here. And that's by Euclid Book 1, proposition number 43. Now he's going to ask you to add the area which is inside here. And this is CGFB. And he wants you to add this area not only to this rectangle, but also to this rectangle. And if you do, then you have a rectangle called AHFB, and it is equal in size, the area is equal in size to rectangle CNEB. Okay? Now, if you were to add AHFB together with CNEB, then you would get two. Okay, you would get twice the area of AHFB. Okay, so twice the area of this would be this here plus this here. And that means that AHFB plus CNEB is the nomen KLM plus the area inside of CGFB. Alright, so the nomen KLM, and the area of CGFB equals twice the area of AHFB. Whew. Okay, now, since BF is equal in size to BC, because Euclid already established that this was a square, okay, he already did that for you, then we can say that twice the area of A. Now, yeah, here's the key here. Since BF is equal to BC, then we're going to call BF BC from now on. Okay, and the rest of the proof we're going to call BF BC. Okay, so twice the area of A, B, C, H. Okay, A, B, C, H. Alright, twice that area is equal in size to twice the area of AHFB. AHFB. So twice the area of this is equal to twice the area of this. Alright, so the nomen KLM plus the area inside CGFB is equal to the area, twice the area of ABCH. All right. Now, DHGN is DACN because AC is equal in size to HG. Okay, so now we're going to call this square DACN. Okay, so the nomen KLM plus BCGF. Okay, so we got BCGF plus the area of DHMN is equal in size to twice the area of ABCH, this whole area right here, twice of that, plus ADNC. ADNC. Okay? So twice the area of this plus this is equal to the whole nomen KLM plus BCFG, which is this here plus this here. Whew. So that means that the nomen KLM plus BCFG plus DHGN is equal in size to ADEB, ADEB plus CGFB. And that's basically the proof right there. All right. Whew. That is a long proof. If you have any questions about this proof, just let me know. Leave a message in the comments, and I will tell you more in a future video, so stay tuned.